Sorry that it's the end of the day. You guys have to sit through one final presentation. Hi, everyone. My name is Jonathan Kelley. Today, I'm here to talk about my vision for the future of high-level Rust. I'm the creator and lead maintainer of Dioxus, a full-stack app framework for building web, desktop, and mobile apps with Rust. At one point, Dioxus was just a small side project that kept me busy during COVID. Now it's a full-blown company with employees, customers, and funding. 2 years ago, I gave my first ever talk about Dioxus at RustNL in Amsterdam. The vision for Dioxus was simple: build the best possible cross-platform app framework, not just for Rust, but the best. I chose Rust because it was fundamentally solving core issues that I found in other frameworks. Packaging is a solved problem. Custom DSLs are easy. Performance is a non-issue. It works on every device, and the IDE tooling is fantastic. Over the past 2 years of building Dioxus, we've learned a lot, not only about building app frameworks, but about Rust itself, both the good and the bad. We have found that Rust excels at building foundational software. Rust seems to accomplish the impossible: eye-watering performance, a high-quality ecosystem, docs, tests, and impressive IDE tooling. Industry adoption is clearly skyrocketing. Every day I wake up and I see new amazing Rust projects released into the wild. And companies like Cloudflare and AWS move over 30% of the internet's traffic with Rust. Microsoft is using Rust in the Windows kernel, and Google is using Rust in Android's ultra-wideband stack. Even companies like NVIDIA, Hugging Face, Anthropic, and OpenAI use Rust across their AI tools infrastructure. There's more out there than you think. It's clear that Rust is a great choice when quality matters. Unfortunately, nothing is perfect. We eventually realized Rust is just not that quick to write. Between the long compile times and the rigidity of the language, our users were simply more productive building apps and web services with existing tools like React and Fast API. For an app framework, this is an existential threat. People want to quickly turn their ideas into reality. It doesn't matter how good their language is. If they can't ship fast, their company will fail. I want to change that. You might be wondering, why? Why should we invest so much time and effort and money and sleepless nights into making Rust better at writing high-level software? Why not just delegate prototyping to a high-level language like Python? Surely, by making Rust more high-level, we would inevitably compromise its ability to build solid foundational software, right? Well, as the saying goes, good, fast, and cheap, pick two. I think we can pick three. The Dioxus team has been grinding away on the high-level Rust experience because we believe Rust is special. Unlike the majority of programming languages, Rust programs have no global runtime, no garbage collector, no built-in executor, no event loop, no baggage. In many ways, Rust is a clean, blank slate. You can develop Rust anywhere, and you can run Rust programs on any device. Rust's mission is to empower everyone to build reliable and efficient software. I don't think that should be exclusive to so-called foundational software. All software starts with a prototype. I fell in love with Rust because every project I could dream of finally seemed feasible. No idea was technically impossible. What if tomorrow I wanted to build an embedded device, or a web app, or a mobile app, or a video game, a robot, a virtual machine emulator? Rust can really do anything. Now, yes, languages like JavaScript are extremely capable. They're popular, they have huge ecosystems, and tons of investment. Hundreds of millions of dollars, billions of dollars. But no matter how good I get at JavaScript, I still can't do something crazy like write a driver for the Linux kernel. We should actively invest in making the developer experience of writing high-level Rust code on par with that of writing foundational software. I hope my passion and enthusiasm for the future of Rust shines through here. I believe Rust is the next 40-year language. Seriously, I truly believe it. That's why I'm up here. I'm so passionate about this. Just like the previous generation of programmers can build an entire career on C, I think the next generation will build their careers on Rust. And honestly, like, what an upgrade. As Rust engineers, we live in a golden generation. Rust is fast, safe, and gives us full access to the hardware. The Rust community is filled with people who care about the right stuff, in my opinion. Things like good documentation, testing, and being open to new ideas. You can't say the same about every other language. We should be careful not to be complacent with Rust as it grows and matures, but we should also not overload it with baggage. The future of Rust, and broadly engineering, is so bright. Rust turned 10 this year at RustNL. Imagine the next 30 years. Today we have incredible libraries for things like web servers, async runtimes, communication protocols. We even have niche libraries like spatial trees and high-quality email parsers. But imagine a world where we can easily pull in libraries for crazy things like robotics, genetics, AI, autonomy, quantum computing, things that haven't been invented yet, things that are typically high level. That's the future I'm working towards. So, enough waxing and waning about Rust. What are we at Dioxus doing to improve the high-level Rust experience? Well, Dioxus is an app framework. I'd say it was the first one, maybe not, with the primary goal of rapidly bringing an idea to production. You write your code once, and then easily port it to new devices with minimal code changes. To date, we have over 30,000 stars on GitHub, which doesn't mean much, but it's something, with apps in production at companies like Airbus and the European Space Agency. Dioxus is unique in this world because Dioxus apps are written in Rust. In our case, Rust is both used in foundational software, the engine, and in high-level development. The apps themselves are written in Rust. So hopefully you can see this. We'll do a little demo later. We'll do a little hands-on thing, but I'll just give you a little screenshot. At a high level, at a glance, the Dioxus architecture is modeled after tools like React and Svelte. Dioxus apps are assembled by composing a tree of reusable components, and components are simple. They're just functions that take properties and return an element. Hopefully this is pretty clear. Application state is stored in hooks, which are these little use functions, use signal, and updated through reactive signals. And we paint all of our first-party renderers with HTML and CSS, which is a good choice. Elements like images, videos, divs, headers, and inputs are freely available. You can style and lay out your widgets directly with attributes, or use the asset macro to include CSS and images from the file system. But most importantly, Dioxus is designed to be familiar to existing developers, lowering the learning curve and making AI tools much more powerful. You can run Dioxus apps on a wide array of devices. You can target the web natively through WebAssembly, or build desktop apps that target all major operating systems like macOS, Windows, and the many, many flavors of Linux. I hate it. Nix, those Nix people, yeah. We're also one of the few Rust projects actively pushing forward the mobile ecosystem. Basically, it doesn't exist. You can quickly write a Dioxus app that runs on iOS and Android. Dioxus apps can even render on the server, supporting features like server functions, HTML streaming, pre-rendering, and WebSockets. Because Dioxus apps are written in Rust, they are structurally very simple. You've seen this structure every time you've created a new cargo project. Very rarely do users need to drop into platform-specific code. Because all Rust projects are alike, it's very easy for developers to dive into a new project. You can completely skip annoying build system setup. All you need is a main.rs to get started. None of the 1,000 tools you would need otherwise. Dioxus apps are written in HTML and CSS, and then rendered either natively or through the system web view. On the web, this means using the HTML DOM, and on desktop or mobile, this means interleaving system widgets with a custom GPU-based renderer. Practically, though, this means that your apps look and feel the same across platforms, just like they would in a web browser. If this sounds like a lot of work on our part to build and maintain, it's because it is. It's very challenging to support. It's basically building a new web browser from scratch. Certainly, on our part, it's a labor of love. Building an app framework is only half the battle, though. Along the way, we've had to solve some gnarly challenges with Rust itself. It's not all rainbows and sunshine. These improvements usually fall into one of a few buckets, either improving build tooling or improving language ergonomics. To make Rust better at high-level development usually means improving the developer experience, basically making developers build faster. So together, in the next couple minutes, we're going to walk through some of these improvements and then have a little live demo at the end. The first thing, or something I'm extremely proud of, is a tool called DX, which is our command line tools. We've been hard at work at improving foundational Rust build tooling. You might wonder why. I mean, cargo is great, but DX wrapped cargo to provide a ton of missing functionality. It can run multiple Rust binaries at once, watch your Rust files and assets for changes, and intelligently reload Rust code on the fly. Yes, it has Rust code hot reloading and app reloading. Two different features, but very cool stuff. We'll go dive into them more. It has so many features, this DX tool, and it's been anchored to the Dioxus ecosystem, but I want to talk about it. You can filter your log levels at runtime. So if you press V, you can get the verbose mode, which lets you inspect deeply Cargo's build system, the Rust compiler, as well as being able to turn on verbose logging for your running apps as they're live. DX supports serving web apps, desktop apps, and even cross-compiling to iPhones and Android devices. DX is a very powerful cross-compiler, basically solving the Rust cross-compilation problem. DX is not specific to Dioxus and can be used with any Rust project. It's a very cool tool. And there are a lot of little details into building good Ratatouille apps and TUI apps. So I got to write a blog post about this at some point. You can copy the lines. You don't need special copy-paste handlers, and there's all sorts of stuff. One of the cool things is you can press D, and it opens a debugger. So if you're using VS Code or Cursor, we don't have Z support yet, you get your app running in a debugger. One thing that's really, really cool about owning your own tools is the ability to instantly hot reload certain macros. So our RSX macro allows us to quickly build HTML, CSS UIs. We can instantly hot reload it in 0 seconds. The hot reload engine is extremely powerful. You can modify the layout, the style, and the content of UI elements without rebuilding your Rust project. It even has the ability to instantly hot reload a limited subset of Rust code, like numbers, strings, and booleans, instantly. The RSX macro is essentially a lighter form of Rust with fewer features and some syntax sugar to make assembling elements easier. But we were able to extract the RSX macro parser and reuse it for a wide number of tasks like auto-formatting, HTML to RSX translation, and the hot reload engine. Rust macros don't natively support things like autocomplete and partial expansion, so we've developed new libraries like partial expression to make it easier to write high-quality Rust DSLs. Partial expansion gives macros great editor support with things like autocomplete, hover support, and high-quality error reporting, like they're just part of the Rust programming language. The architecture here is very interesting and maybe something you can leverage in your own projects. While watching users build Dioxus apps, we noticed many people struggle with the verbosity of Rust around callbacks and spawning asynchronous work. Rust enables fearless concurrency, but at times it's not very ergonomic. This shows up frequently in UI code, where pretty much everything is a callback or asynchronous work. So, to fix that, we built a generic crate called generational box. Generational box completely removes the need to call .clone on values used in callbacks by wrapping the underlying data in a smart pointer that implements the copy trait. The copy trait is special because Rust automatically inserts calls to .clone for us. This behavior is critical to making async Rust code ergonomic, but it does have some fundamental limitations. Ownership of values become non-obvious, forcing us to move some compile time guarantees to runtime checks, such as the cost of high-level Rust. The generational pointer enables copy ergonomics for data that follows a hierarchical program structure, basically directed nodes in a tree. It's written in entirely safe Rust and adds only a very small overhead. As long as some data has a clear parent or owner, either its container or another node in the tree, it can be freely used without explicit .clone calls between callbacks, tasks, and even system threads. And the benefits are real. The smart pointers make writing callbacks and current code much easier, sometimes even simpler than in languages like JavaScript. I do want to mention that we want to add the ergonomics of generational box to Rust itself. Generational box is a great prototype, but we want everybody to have this. So we proposed a project goal to add lightweight clones to Rust for types like reference-counted smart pointers. And that's not my name up there, that's Josh Triplets. It's a controversial change to the Rust language. Not everyone might agree, but in my opinion, it's critical for high-level Rust to succeed. Yeah, see, not everyone clapped at that. There's split opinions. You can use generational box for now. We've also, so this is less about the language, but more about the ecosystem. We've been working to push forward the Rust ecosystem in a wide variety of ways, much to the Herculean effort of Nico Burns. He's not here, he's in the UK right now. One of those is by developing a modular HTML and CSS renderer called Blitz. Blitz is the foundation of our next generation rendering engine that interleaves native system widgets with a custom GPU-based draw layer. As we've worked on Blitz, we've improved Rust crates across the ecosystem, like Taffy, Parley, Velo, Winit, and Servo itself. Things that implement Flexbox or text layout, rendering and windowing. We are trying to dog food everything in the Rust ecosystem and like really compete with the native toolkits. I think Blitz is really freaking cool. Because it's modular, it works very well with the rest of the Rust ecosystem. I think the Blitz repo is like 12 different crates, so you can pick and choose what you want to take. You can composite in arbitrary GPU textures and integrate it with other libraries that speak WGPU, stuff like Bevy. So this is actually a Bevy game embedded in a canvas running natively. This will work on your phone and works in the web. You can even like add custom elements, so if there's not a div that suits you, you can make a new div. Blitz can embed almost anything and can be embedded into almost anything. So in this case, Blitz is actually embedded into Bevy. So it's very modular, it works with the rest of the ecosystem. Unlike existing solutions, Blitz is free, open source, and extremely modular. So our goal is to provide a browser-grade rendering engine free to everyone. You don't have to pay a licensing fee. We can render a huge amount of the web today with sites like Hacker News and the BBC rendering beautifully. There's a long road to support all of CSS and layout, but it's actually quite great today. So, is that cool? I don't know. Now for the really cool stuff. It gets cooler. The stuff I've showed so far is pretty cool, but it's not even close to the most interesting innovations we've made thus far. 2 years is a long time. At a certain point, we need more power than Rust itself can provide. Fortunately, a little esoteric thing called a program linker can provide the muscle. Program linkers are programs that take a collection of compiled assembly files and system libraries and combine them into a single output executable. It's the last step when you run a cargo build. Linkers are special because they're the one tool that has complete visibility into your entire Rust project. Our first experiment with using the linker was to develop a generic asset system for Rust. This means including things like images, style sheets, videos, 3D models, all these things into your app, some of which can be very large. We didn't want to simply use the include bytes macro. Include bytes literally just copies the bytes from the file into your program's data section. For platforms like web and mobile, you really want your assets to load in parallel with the main binary, not be embedded in it. Our asset macro actually includes only the metadata about the assets in the main binary, like their path in the file system and some configuration options. The crate that backs this is called const serialize. So you can do const serialization and deserialization. You compile your project like normal, And then a post-processing step extracts the metadata by parsing special linker-only sections of the main binary's data segment. We use this metadata to locate the assets on the file system, optimize them, and copy them into the final bundle. Users get features like asset hashing, caching, optimization, and over-the-air updates for free. Once we properly understood how to use the linker, we embarked on a much harder project, WASM bundle splitting. Bundle splitting breaks large binaries down into smaller chunks that can be fetched and lazily loaded on demand. This is a key feature widely used in the JavaScript ecosystem that helps apps load quickly, no matter how many screens you add. Unlike the asset system, our WASM bundle splitting feature actually rewrites your app's assembly in place. We read the special linking section of your binary and create a call graph of every function using the linker's relocation entries. Normally, relocation entries are used by the linker to maintain a list of fix-ups required to create the final binary. But in our case, they provide a natural map of your code for us to intelligently break it apart. This map guides our assembly rewriter to split isolated sections of the call graph from one another. An app with 100 different screens can easily become 100 small chunks. This feature reduces initial bundle sizes from tens of megabytes to just a few hundred kilobytes, making Rust a viable target for the web. OK, last one. Subsecond. This is the coolest demo of the presentation. Subsecond is a hot patching engine for Rust that lets you modify and update Rust functions at runtime. Hopefully you can see the video. This is a client and a server, so two separate binaries running in an iOS simulator, and we are modifying the Rust code and seeing updates propagate in 400 milliseconds. If you're using a supported library framework, your code requires no changes to support hot patching. Simply dxserve --hot patch, and you get Rust hot reload for free. Subsecond is exciting because it keeps you in the flow. You can quickly tinker with values, behaviors, logic, and content without closing and reopening the program. Subsecond is fast. Most hot patches take less than a second, and some small changes can take less than 0.1 seconds. Subsecond is not just limited to Dioxus. We built adapters for frameworks like Ratatouille and Axum, and projects like Bevy and Iced have already integrated the protocol into their main repos. These demos showcase how effective hot patching is for high-level Rust development, shaving off hours of what would have been slow and painful iteration. And if you've ever built a video game with Rust or a TUI app with Rust, being able to see this update live, it's like magic. It still looks like magic. In my opinion, Subsecond is a marvel of engineering. Not to toot my own horn, but it sidesteps the traditional cargo build system, almost entirely eliminating the expensive linking step that slows down incremental development. We initially compile a fat binary that includes all generated assembly. As you modify your Rust code, we recompile just the crates that change and incrementally link them against hard-coded addresses in the running program. This process is extremely fast and efficient, hence the name Subsecond. Note that this technique is not specific to Rust and can even work for C, C++, and Zig. Building Subsecond was quite challenging. I don't know if you can see any of the code on here. There are a huge number of quirks, edge cases, obscure behavior, all these crazy things you need to work around to make it function. But we support all major platforms, even mobile and WebAssembly. This means handling things like architectures, calling conventions, thread locals, and even weird platform-specific quirks like the Windows linker, or kernel hardening, or address space layout randomization. Fortunately, the results are fantastic. We've been watching people use Subsecond to develop games, iterate on front end, build back ends, and even do 3D modeling. We are excited to completely spin out Subsecond from Dioxus so everyone can benefit. And our goal is to what I call grow the pie. High-level Rust is quite nascent. Tools like Subsecond are young and just starting to pave the way for Rust up the stack. We want everyone in the Rust ecosystem to be more productive, even other app and GUI frameworks. It looks like I have some time for a quick demo. Let's see if it's... All right, hopefully you guys can see this. Is it too big, too small? Perfect. OK, good. So this is a simple Dioxus app. There's not much going on in it. We have an agents.md file. If you're an AI person, it's a lot smarter at writing Dioxus code than it would be otherwise. Every Dioxus app starts with a main function, and we have a launch. Components are just these like little idents and curly braces. So there's this echo component down here. We have a hero component down here. It looks just like HTML and CSS. I don't know if you've seen Rust look like this before, but it's we try to make it as elegant as possible. And then we have our command line tools. So here we can DX serve. Yeah, we'll do hot patch, platform, and then we'll do desktop. OK, so we have a very cool little embedded GUI in the command line tools. It's interactive, so if we press R, we can reload the app. That forces a full rebuild. We can press V, and we can do it again, and we get even more logs from inside of the build system. And then we can go and start hot patching things. So let's say hello from the server. Hello. Let's modify what the server has to say. So we can come over here. Server says, we can delete this, save, and then we hot patch. No. Look at that. So that was pretty quick. The live demo worked. I think it's a success. We can even do mobile development just to prove that it works. We automatically launch the emulator for you. It takes a little second to churn. Same deal. So if you can believe me that it supports web, desktop, and mobile, we'll show off these platforms for now. Yeah. All right. Let me come back. Cool. So I don't have time to showcase more other of the cool things we built. If you are excited, as I am, to push forward high-level Rust, definitely check out all the stuff we're working on. We're actively working on hard problems right now, like better FFI and a comprehensive expanded standard library for Rust. There's a number of language improvements we would love to make to Rust itself, like pre-built crates, a faster codegen backend, automatic clones, partial borrows, and named function arguments. There is great momentum in these areas. People are excited, but they are woefully understaffed. If you want to help get involved, consider contributing to Cargo or help write good RFCs to get high-level Rust features stabilized. If there's any thought I want you to leave with today, it's that high-level Rust is extremely important to Rust's future. I want the next generation of scientists, researchers, and entrepreneurs to have the best tools possible to make the world a better place. Improving the high-level Rust experience means that we not only build great foundational software, but we get to use it too. The future is much closer than you might think. Thank you.